Hey guys, I wanted to do one of the homework problems. I have a couple of students who asked me about it, and I did post the solution under Ask the Professor, and I also under Module 1. If you look at Module 1, the very last item, you will find that solution to that problem. But despite that, I thought maybe right before the end of the week, maybe I should solve this problem in a video, so just to make sure that you guys understand how to work out with vectors. So basically the problem says I have the xy coordinate like this. Whoops, there we go. So here is my x and y coordinates. Oops, not the y, not good. It's always difficult for me to draw a vertical line. There we go. And then I have a vector that looks something like that. The vector, we're going to call that vector C, is in the homework, and this is the angle 22. The length of the vector, or the magnitude of the vector, is 4.8, and then we have another vector like so, and this angle is 33 degrees, and this is vector B, and the length of the vector is 5.6. Okay, when you say length means magnitude, the same thing, right? Okay, so basically what he's saying here is that find vector D such that this D is equal to B minus C, So whatever the combination of this D, all you need to do is the following. See, if I have a vector D like this one here, and it is equal to a combination of those two vectors, it happens to be that B minus C. What that means is that the x component of D will also be equal to the x component of B minus the x component of C. And the y component of D will be equal to the y component of B minus the y component of C. Do you see what I'm saying? So basically what that means is that D sub x will also be equal to B sub x minus C sub x. These are not vectors, remember, these are components, magnitudes, and then, or scalar values, that is. And then D sub y will be equal to B sub y minus C sub y, okay? So now, basically, I have reduced the problem from a vector form like this one, D vector equals B vector minus C vector, into components form, which is the D component, the X component of D, and the Y component of D, okay? So now my job is to find the X and Y component of C and B. Once I know that, I can plug them into those two formulas, and then I would get the X and Y component of D. Do you see the plan? Okay, so let's do that. So I'll start with, for example, B sub X. B sub x, as you can see, it will be the vector B cosine 33. And if I would calculate that, so I have here 5.6 multiplied by cosine 33. And I'm going to use a calculator. If you are working with me right now, can you please use your calculator? Make sure that you are getting the answer that I'm getting. So cosine 33, multiply this by 5.6, and the answer is 4.7, okay? Keep in mind, look at that, I forgot to mention one thing. Back to the graph here, change the color. So let's say, for example, oops, this one here. Notice that the B sub y and B sub x, this is B sub x right here, and this is B sub y. Notice both of them are negative, right? So B sub x here is in the negative side of the x-axis, and B sub y is below the y-axis. Remember, the y-axis is here. That's negative. So both of them are negative. So that's basically what I'm going to do. I'm going to put a minus sign here. I want to be careful. And then the final answer in this case, it will be negative 4.7. You see what I'm saying? Okay, now let me change the color. And now we have B sub y. Again, B sub y is also negative, as you can see. So that will be, let me put a negative here. I forgot to mention that. So that's going to be negative B sine 33. And that will give me negative 5.6 times sine 33. Let me use my calculator. Sine 33 is equal to 0.545 actually. And then when I calculate that, I will end up with -3. Okay, so there we go. Now let's do the c sub x and c sub y, the x and y component of c. So notice that c sub y is going to be right here. Let me use a different color. For example, so this is c sub y would be right there, and that's negative, right? Because it is below it's below the y-axis. And then, however, notice that c sub x, it's this one here, and that will be positive because this is the x-axis that is positive. Okay, so keep that in mind. So in this case, we will have c sub x will be equal to 4.8. 4.8. Let's look at the angle here. That would be 4.8 sine 22. And when we calculate that, I will end up with 1.8. And then c sub y is equal to -4.8 cosine 22. And the answer in this case would be -4.45. Okay, so there we go. So now I have resolved all the two vectors into x and y components. Okay, that's really the hard part of the problem. The second, now all I need to do is to plug in those components into d sub y and d sub x till I get the vector. You see what I'm saying? So let's start with the d sub x. So we know that d sub x is b sub x minus c sub x. So that basically what? B sub x is right there. It's negative 4.7, and c sub x is 1.8, so we just plug it in there. So it's going to be -4.7 minus 1.8. And when I calculate that, I will get minus c sub x. I'm sorry, c sub x is positive here. Sorry about that. So it just, I hope I didn't confuse you. C sub x is positive. So in this case, I already have a minus here. So that's b sub x is -4.7 right there. And then minus 1.8. Is that right? And then when I calculate that, I will get, so again, minus this will give me -6.5. So d sub x is -6.5. Now d sub y is, it's right there. B sub y minus c sub y, both are negative in this case. So we have here b sub y minus c sub y, and then I will have -3 minus 4.5. 4.45 actually. 4.5, and when we calculate that, you'll end up with 1.45 for d sub y. There we go. So I have d sub x is this d sub x right there is -6.5, and d sub y is 1.45. And now I want to get d. He said find the magnitude and direction. So what is d in this case? Well, first of all, let's find the d vector. So the d vector basically d sub x I plus d sub y j. I'm not sure if you're familiar with this vector notation. If not, you can ignore it. And that would be basically, so the d vector would be something like -6.5 I plus 1.45 j, and that would be the d vector, okay, the vector form. I'll come back to it in a second. I want to show you a drawing of it, but let's get the magnitude of it. So we want to get the magnitude. So the magnitude, as you know, if I have a vector, let's say a equals a sub xi plus a sub yj, that's a vector. So the magnitude of that would basically equal to the, the Pythagorean a sub x squared plus a sub y squared, right? You basically take the x and y component, you square them, you add them up together, and take the square root of that, just like you're getting the length of the hypotenuse, which is basically that. So anyways, we're going to do that. So therefore, the d magnitude, okay? Another way of writing it is like this. I think if you've seen it in the math books, let me write it better. So I have, you can either write it as d without the vector on top of it, or you put those double bar like that. Kind of an ugly symbol, but that's how they do it in math. And then it will be something like d sub x squared plus d sub y squared. And then we can plug in our values. I want to stick with the d without the vector form. So that will be basically square root of negative 6.5 quantity squared plus 1.45 quantity squared. And then when I use my calculator, and I will get the final answer to be 6.6. I hope I did it right. So there we go. Check my answer, please. And there we go. So I have, this is the magnitude of the vector. You see what I'm saying? Okay. Now he's asking the second, I think there is a second question. He's asking for what is the direction of the vector. So direction of the vector. Now, when the word direction is being asked, what that means, what he means by that is basically at what angle with respect to the x-axis. For example, let's say in general, so let's say I have x and y like this, okay? Let's say I have a vector, let's call it A here, okay? Let's say the magnitude of it is 5, for example, and let's say the angle with respect to the x-axis, let's say 60 degrees. So we say the magnitude, mag, of the vector is 5, and the direction there is equal to 60 degrees, WRT x-axis. WRT means with respect to the x-axis, okay? So this is basically the direction, okay? Well, I mean, we don't usually say it is north, east, or southwest, or something. We just simply, all you need to do is to, what is the angle with respect to the x-axis, starting usually from the positive x-axis, not from the negative, okay? You start from the negative, from the positive x-axis, and you start measuring the angle, okay? So let's do this, apply this idea to our vector. So recall, our vector looks like this, here it is. Okay, so I'm gonna write it down again. Negative 6.5 plus 1.5. Let me just write it down again. Here is the vector. So our vector equals to negative 6.5 I plus 1.45 J, all right? So what that means, let me put it in x and y coordinates. So here is the y axis. Here is the x-axis. So if I go to the x-axis, so it's 6.5. So if I would, put the marks here, so 1, 2, 3, 4, 5, 6, 7. 6.5 is roughly here, okay? I'm kind of eyeballing it. And for the y-axis, I'm sorry, this is negative. I beg your pardon. This is negative right there. So I need to go to the other side. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7 right here, and this is negative 7. So negative 6.5 is right there. And then we have for the y-axis 1.45. So let's say this is 1 and this is 2. So 1.45 is roughly here. And if I would extend it like this, okay, what I will get, here is the vector. Roughly, I'm having difficulty using the pixel and getting that vector. Let's suppose this is the vector right there. It's not the best looking vector, but here is the vector that we have, okay? So what he's asking for, what is the direction of the vector? Again, as I told you, what you do is you always measure the vector from the positive x-axis. So basically what he's looking for is this angle. Let's call it theta. That's what he's looking for. You see what I'm saying? So how do I find this one? Well, there is a little trick to it. The best way to do is to first find this angle. Let's call it phi, the Greek letter phi. Okay? I can find this angle. See, what I'm looking at here right here. I have to move my mouse to show you the cursor. So it looks something like this. We have a triangle, something like that. This is the angle phi, the one you're looking at. This is the d vector right here. Oops, d vector. And this is dy and this is dx, correct? So how do I find the angle phi? Well, it is tangent. See, tangent is opposite. Tangent is opposite over adjacent. So that means dy over dx, okay? So what I can do to find this angle phi, so tangent phi is opposite dy over dx. So therefore, phi is the tan inverse of dy over dx. You see what I'm saying? So when I do that, tan inverse of dy, what's dy? dy is equal to 1.45 divided by negative 6.5. And when I work it out, if you use your calculator with the inverse tan, you'll end up with negative 12.57 degrees. The reason for the negative, because we are measuring it from the other side. See, this is the positive way of measuring angle from the positive axis, but we are measuring it this way, in this direction. That's why you get that minus. You can ignore it if you want to, but that's the meaning of it, okay? So there we go. So now I have this angle to be 12.57. So what would this angle be? Simple. All you need to do is subtract 180. Remember, this, the angle from the positive all the way to the negative is 180, correct? Straight line. So if I would subtract 180 from the 12.7, that will give me theta. That's what he's asking for. So therefore, theta would basically be equal to 180 minus 12.57. And when I do that, I will end up with, let me give you the precise answer. 180 minus 12.57. Answer, I guess, 167.43 degrees. The answer in the book, I believe, is 168. That's pretty close, okay? I think it has to do with the rounding, the way we rounded things out. But anyway, there we go. And that will be the final answer. So therefore, the direction of the vector d, the direction of the vector is basically 168 or 1.67.43 with respect to the positive x-axis. You see what I'm saying? And the magnitude of the vector, this is the vector right there. But the magnitude of the vector, which is basically the Pythagorean, which we got right there, that would be the magnitude. Okay, so this is the magnitude, and this is the direction right here. That's direction here. Okay? That's all. I just wanted to explain this problem for you. If you have any question, please let me know. If you want me to do another video like this on another problem, I will be more than happy to do it. Just let me know which one. Bye-bye.